Hello. In this last video in the SQL review series, I will address some points related to real-world SQL query writing. The number one point I would like to address is that it's important to understand the schema of the database you are querying. Primarily, this relates to the data types as well as the relationships that have been defined between the tables. It is important to understand the data types that have been used to define the fields in the tables, because we must be able to provide proper literal values when required, as well as understand which fields might be joined to which other fields. Data types, of course, can include things such as currency types, any of the many date types that SQL Server 2012 currently supports, numeric values, which might include both integer as well as real values, which are still distinctly different from the currency data type, and some of the newer, less common types such as geography and geometry. Relationships are important to understand because those will form the basis for creating joins between tables in our queries. Most commonly, the joins that we will define in our queries will follow the relationships that have been defined, and the join keys will become the primary and foreign keys that make up those relationships. If a database diagram is not yet available for the database you are working with, you should consider creating one. You can create a database diagram using the built-in SQL Server Management Studio tool, or you can export the schema to a tool such as Visio or even more specialized case tools. Secondly, we need to understand the question. What is the end user looking for in terms of data? Do we properly understand the terminology that the end user is using? Such as when we are talking about a total sales amount. Are there any discounts that need to be applied? Should we be considering returns? And so on. What will the information be used for? This may be important because it will help us frame the context and possibly help the user develop a more refined query than what might normally be obtained. It's very important that if you have any questions about the concepts or the purpose of the query, to ask the end user for clarification. This will avoid either lots of going back and forth between the end user and yourself, or alternatively, it will avoid the end user from using incorrect information for important purposes. Number three, as you are developing complex queries, you should consider following a disciplined approach to developing the query step by step. First, we might develop a query that has virtually no or few filters. In other words, restricting the where clause to the absolute minimum number of conditions that we can afford to use. Secondly, we may add joins, paying particular attention, of course, to the join keys, which again, in many circumstances, will relate to the primary and foreign keys used to define the relationships between our tables. Third, we will go and refine the where clause to make sure that we filter out any rows that are not needed. In a fourth step, we may perform aggregation and grouping, and possibly even further filtering using the having clause. And finally, and only if needed, we will apply a sort order. Let's look at an example. A user might require you to find the customers in the United States that have ordered at least 10 men's sports shorts in any size in the previous 12 months. If we consider the question that the user has asked us to answer using the AdventureWorks 2012 database, we might find that we do not have sufficient information. When we ask for some clarification, we might obtain, for example, the specific columns that the end user is expecting to see. So the query might change to finding the customers in the United States that have ordered at least 10 men's sports shorts in any size in the previous 12 months, and we need to list their customer ID, title, first name, last name, and the total number of shorts ordered. Let's work through this example step by step.
So here is a blank query editor window connected to the AdventureWorks 2012 database. In step 1, we are going to develop a query with few filters. As we are expected to list primarily customer information, we will take this step first. AdventureWorks 2012 as a database is very highly normalized And this unfortunately already requires us in our first step to provide a join clause. We will be able to select the customer ID from our customer table, which is in the sales schema in this case. However, in the customer table, we do not find information such as first name, last name, and title. That information is found in the person table. So we will join customer to the person table, which is in the person schema. And we are going to join the business entity ID in the person table to the person ID column in the customer table. This does not sound particularly natural, and it is a result of the particular decisions that were made when Microsoft developed the AdventureWorks sample databases. Now we can include the title, first name, and last name columns. We can execute this query and take a brief look at the initial results. This looks satisfactory. This is the type of list that our user is looking for. Of course, we will need to add the total number of shorts that were ordered in a later stage. Now in the next stage, I'm going to apply some filters. The basic filter would include limiting our customer results to only those customers that live in the United States. In order for us to do that, we need to once again start applying some joins. The customer table contains a foreign key territory ID, which refers to the sales territory table in the sales schema. So we will address this join in the second stage. So we will join with the sales territory table and alias it as ST and join on the territory ID columns. Now the sales territory table unfortunately does not contain the name of the country. It contains the country and the region code. The name of the country is found in the country region table, which is part of the person schema. So we will need to join on it as well, using the country region code as the key. Now remember that being able to write these joins involves understanding the schema. I have previously already looked at a database diagram for the AdventureWorks 2012 database, and I understand the different tables that are involved as well as how they are related to each other. Now I can write my first where condition, where I'm looking for the country or region name to be equal to United States. And rerun the query indicates that I currently have 8,210 customers who meet my criteria. Of course, a very important secondary criteria is related to having actually ordered the sports shorts. Now, sports shorts is a product that would have been ordered through a sales order. And a sales order itself consists out of two tables, the sales order header and the sales order detail. So we will need to join both of those tables. Notice that I'm purposefully leaving a blank line, which is simply to make my different joins more relatable to each other. So I'm going to join sales order header using the customer ID. And I'm going to join the sales order detail using the sales order ID. In addition, I will also need to find the product using the name of the product, which will require me to join one more time using the product table. The product table is found in the production schema in this particular database. And we will use product ID as the join key between the sales order detail table and the product table. In our third step, refining the where clause, I'm going to add the additional columns that I need to create conditions. One of my conditions involves making sure that the order is placed within the past 12 months. So I'm going to create a condition that uses the order date, and I might do something that requires my order date to be greater than the result of a function that uses the date add, but instead of adding 12 months, I will subtract 12 months. Meaning that if I subtract 12 months from today's date, which I obtain with the getDate function, I'm going back 12 months, and if the order date is greater than that date, that means that my order was placed within the last 12 months. Now, if we execute this query after disambiguating the customer ID field in my select clause, I will end up with 0 results. This is an unfortunate side effect of using the AdventureWorks 2012 database, which contains lots of rows and lots of data. Unfortunately, it does not contain any data from current time periods. So I'm going to change this function where I subtract 12 months from today and instead subtract 12 months from October 1st, 2006, just to make sure that I have some results. To compensate for this and to make sure that I'm only returning results within the previous 12 months from October 2006, I'm going to put a second clause that requires my order date to be less than October 1st of 2006. Note that these two modifications that I have just made are simply only required because I am querying a database that does not contain current values with values that are several years old. If we execute a query now, once again I have customer results. The second part of my refining of the where clause involves querying for the proper product. And I know that the product name is men's sports shorts, so I'm going to use this query, which is going to select from the product table where the name is like sports shorts, just to get an idea of the types of products that I'm dealing with. So I can see that my men's sports shorts have a name of men's sports shorts, then a comma, and then a particular size, small, medium, large, or extra large. Now, there might be different ways of handling this requirement. I could find the product IDs using this method first, and then list them all individually in a where clause, perhaps with an in comparison operator. Or I could take the product number, which certainly looks very similar for each of these sports shorts, and then add a simple wildcard at the end, or I can use a wildcard on the product name. Your specific requirements may vary. In our case, the best choice might be to query based on the product name, and that's what I will do. So I'm going to say that my product name should be like men's sports shorts, comma, space, and then a wildcard. Now you notice, based on the syntax highlighting, that something is not quite right. Because I have a single quote in the actual literal value that I'm looking for, SQL Server will treat this single quote as the ending of my literal value. So it's actually treating my query as reading product name like men. And then whatever comes after that will be treated as further SQL statements, which of course don't make sense. When you're faced with a problem like this, usually it involves some type of escaping. In the case of escaping a single quote, so that SQL Server will treat the single quote as a single quote that's literally part of the value that I'm searching, it involves simply doubling up that single quote. Notice this is not the same as typing a double quote single character. We double up two single quote characters. Now when executing this query, I've just retrieved a list of all the customers that have purchased men's sports shorts in any size in the past 12 months, or in this particular instance, in the 12 months preceding October 1st, 2006, and who are located in the sales territory United States. Note that this customers list is not unique. There will be many repeating customer names. In step number 4, I'm going to perform any required aggregation and grouping. Now I know that this query is going to return duplicate customer names. That's not what I'm interested in, so I'm certainly going to need to group by these current values that are shown, by the customer ID, the title, the first name, and the last name. Doing this grouping results in a total of 58 rows that are each unique. So I have 58 unique customers that have purchased men's sport shorts in the 12 months preceding October 1st, 2006, and whose sales territory is the United States. I have not yet met all my requirements though. My requirements also involve making sure that I'm only listing those customers that have ordered at least 10 of those sports shorts, as well as including the number of shorts that they have ordered. So this involves aggregation. And in this case, we will sum up the order quantity field, which is found in the sales order detail table. That will give me the total shorts that each customer has ordered. Now we can see that I have many customers who do not meet the requirement of having ordered at least 10 of these shorts. So we will now add a filter to the query, which will eliminate the customers who have not ordered at least 10 of these shorts. Now this cannot be done with a where clause because the where clause operates before the grouping and aggregation is completed. So this involves using a having clause where we will repeat the sum operation and say that we need at least 10 total order for shorts. So at least 10 means greater than or equal to 10. And we can now execute this query, which is our final query, listing all of the customers in the United States that have ordered at least 10 men's sports shorts in any size in the previous 12 months. And we are listing their customer ID, title, first name, last name, and the number of shorts that they have ordered. So we have now used a 5-step process to develop this query. Step number 5 might involve sorting, and for business purposes we might want to sort this particular query by last name and then following first name. In this case, I'm going to skip this step and return to the slide deck.
Now that we have completed our step-by-step query writing using this example query, I have 2 more points I would like to highlight. It is very important to consider what's referred to as pivotal values. As in the query example we've seen, we needed to produce a listing that included customers who had ordered at least 10 units of a particular product. It's important to clearly understand what the pivotal value here is. The pivotal value is 10. So we will need to consider if the value 9, 10, and 11 should or should not be included. So we need to consider if a customer ordered 9 shorts, should they be included? The answer is no, because they have not ordered at least 10. Should they be included if they have ordered 10 shorts? The answer is yes, because 10 is part of having ordered at least 10 shorts. And of course 11 should be included as well. Based on this analysis of these pivotal values, which are the values that immediately are around our key value of 10, naming 9 and 11, is going to be critical to determining the proper comparison operator, which in our case was greater than or equal to. It's also important to consider, of course, if customers who have ordered at least 10 should be included or excluded. Remember that our where clause is going to determine the rows that match the criteria, and those rows that match the criteria are going to be included in our result set. And a final and 5th point is considerations for performance. Now, performance is generally outside of the scope of this academic course and this review. However, there are a few pointers and techniques that you may want to consider. First of all, don't query more than what you need. In our preceding SQL example, I queried rows from the customer table, sales order header, sales order detail, and product. I also queried sales territory and country region tables. Potentially, I might have been able to eliminate some of those tables by immediately providing key values or ID values instead of their names. This can significantly speed up query performance because that would reduce the number of joins I have to make in my query. Secondly, it's important to learn about the query plan, both the estimated and actual query plans. Exactly how to do that is outside of the scope of this video, but SQL Server Management Studio allows you to view how SQL Server is going to execute your particular query. Using that information, you can then identify the parts of the query that take particularly long to run. You can also identify whether or not your query is using the indexes you were expecting your query to use. Indexes are very important tools in making sure that your queries perform optimally. Thank you for watching this last video in the SQL Review series.